Hello everyone, welcome to my channel. It's me, Dr. V. Jayakumar. I make lecture videos for the benefit of mechanical engineering students. The popular method used for solving problems of dynamic balancing of rotating motors is Dolby's method. So in this video, we will be giving you the key concepts involved in Dolby's method. Before we proceed, I request you to press the subscribe button and also the notification bell icon so that to get notified whenever I post a new video on this channel. So let's get started. What is that problem? For simplicity, we have shown here four rotors, namely A, B, C and D, which are revolving not in the same plane. So they are revolving in different planes. When masses are revolving in different planes, we need to take care of balancing of forces as well as balancing of couple. Then only the system will be in complete balance. When system is in out of balance, how we need to balance it? Usually we will be adding two balancing masses in two different planes. To attack this problem of dynamic balancing, the most popular method used is Dolby's method. People directly solve a problem, but without understanding the basic concept of it, it will not be much appreciated. So we will discuss now the Dolby's method. We are going to add a balancing mass in a particular plane. We call that plane as a reference plane. So the Dolby's method gives us the technique to transfer the centrifugal force acting in each mass, in each plane to a reference plane. Once all forces are transferred to a reference plane, then the procedure of balancing is almost same as that of balancing of several masses rotating in the same plane, right? Now let us understand how to transfer a force from one plane to another plane. Assume we have already having force F in plane A. I need to transfer this force to another plane which is known as reference plane or plane B. If you could recollect, in statics we have studied this concept. I will introduce two equal and opposite forces in plane B. Now can I say that system is equivalent? Because both are same force, literally they will get nullified. So this force is transferred here. Now think of this force and this force. Can you get it? Two forces which are equal in magnitude but opposite in direction. What it will form? It will form a couple. So force multiplied by that distance, we will get moment of a couple. What is important is how to determine the direction of moment of couple. The direction found by using right hand screw rule. Now what happens? These two forces F into L will create clockwise couple. So what you need to do is you should be keeping your right hand in such a way that the right hand is perpendicular to the plane containing those two forces. In this case, this is perpendicular to our screen. I'm keeping, what is the direction? Either I have to keep inwards or outwards. That should be determined by whether your couple creates clockwise or counterclockwise. So keep your finger there. Perpendicular direction of this thumb gives the direction of the couple vector. This direction is known as axis of rotation of the couple. About that axis, it makes clockwise couple. You can see that is shown in the blue. That is known as sense of rotation. So this is the summary. The effect of transferring a force acting in a plane to another plane, which will be equal to the same force F in magnitude and direction plus a couple of magnitude FL. So we will have force plus couple F into L. Okay, that's the first point. The second point is the couple vector is perpendicular to the force vector. Now let us come to illustration of a Dolby's method. What we have discussed is for a transfer of single force from one plane to another. Now assume we have four masses. This is the couple due to mass 1. This is the actual direction. How we got the direction? Using the concept that we have discussed. Similarly, this is the couple due to mass B, couple due to mass C, couple due to mass D. What the Dalby has done, this is the actual couple polygon. He just rotated the actual couple polygon by 90 degrees so that the direction of centrifugal force and the associated couple are in the same direction. What is that idea here? This is the direction of centrifugal force. This is the direction of couple, associated couple. This is the direction of centrifugal force of mass B. This is the direction of couple due to mass B. This is the direction of centrifugal force due to mass 3. This is the direction of couple due to mass 3. So both are in same direction. This is the Dolby's method. That Dalby's idea is if you rotate couple polygon by 90 degree so that couple vector is parallel to the force vector. By doing so, the relative position between the various couples have not changed. So it doesn't affect our answer because of rotation by 90 degree. That is the idea given by the Dalby. So now we got the force polygon. The idea is force polygon, couple polygon will be different because magnitudes are different, but at least my job is made easy because their directions are same because of this simple technique given by him. That's all. This is a summary. In balancing problems, it is convenient if couple vectors are drawn by turning them through 90 degrees in the same sense. That is by drawing them parallel to force vectors. This does not affect their relative positions. What is the advantage of Dolby's method? To draw actual couple polygon, we should be applying right hand thumb rule to know the actual direction of couple vector, which requires three-dimensional visualization technique, which is cumbersome when many forces are involved. So construction of couple polygon becomes much easier due to this Dolby's method. These are the 4 steps that we are going to use to solve problems on balancing of several masses revolving in different planes by graphical method, which we will be doing in our next video. That's it. See you in my next video. Take care. Bye.